length x of a rectangle is decreasing at a rate of 5 centimeter per second and the width y is increasing at a rate of 4 centimeter per second. When x is 8 centimeter and y is 6 centimeter, find the rate of change of the perimeter and the area of the rectangle. So the question is something like this. So we have a rectangle. In this case it's a square, but anyways you guys can take it to be a rectangle. So one of the dimension is increasing while the other is decreasing, right? So we can see the length over here is increasing and the width is decreasing. The height is increasing while the breadth is decreasing, right? This is what is happening. So something like this. Within a matter of second will turn to something like this. Right? So if the length x of a rectangle is decreasing at a rate of, so the length is decreasing at a rate of 5 centimeter per second. Say the length over here, left to right, say this is around 20 centimeter. This becomes 15 centimeter. This is your length. And the width, if this is around say 40 centimeter, the width over here will be 44 centimeter. All of this is happening within a fraction of a second. So this is what you guys have to understand. So this transition is happening within fraction of second. Right? This is what is given. The length is decreasing while the width is increasing. So we are looking at the perimeter and the area and all of that. Now, so it's very clear. It's a simple straightforward thing. We have the width and the length. So area of the rectangle and the perimeter of the rectangle and all of that. So it's directly linked to this. Okay, so we have been given, I'll directly write it, dw by dt and dl by dt. So there are two quantities that we are dependent on, width and length, and we are looking at dA by dt and dP by dt. Okay, I'll just do one of it so that you guys are not confused. So there's direct link, so we don't have to establish anything. Okay, so let's start off. We have been given the following information. We have the rate at which the width is increasing is, where is it? Rate of 5 centimeter, the width is increasing at plus 4 centimeter per second, while the length is decreasing. So what should I do over here? It should be minus 5 centimeter per second. That's the difference. If you guys don't write negative, then you are gone, as it's decreasing. Very important, don't miss that. Okay, so we have this now. So next thing is we need to figure out dp by dt at length is equal to 8, right? I think length is 8 centimeter and we have width, y is width, right? Increasing width, yes, double confirmation, 6 centimeter is equal to what? Similarly, we need to figure out the same thing, right? Instead of dp, it is dA, the same thing. Okay, so these are the two things that we are looking at. So next thing we'll do is we'll write the formula. So we can start off with perimeter or area, doesn't matter. So we have area of the rectangle. So first thing is, I think it's perimeter. We'll go sequentially. Perimeter. Okay. Perimeter of rectangle is given by 2L plus 2W. These are the variables that we are using. Now we can differentiate P of L comma W. I should have changed the representation with respect to T. Okay. So we call this as P of L by W. Now differentiating P with respect to T, right? Again, there are two variables. That's why you have written PL comma W. So this would be 2 times of differentiation of length with respect to time. Well, we get 1. But as per the chain rule, we need to have this as well. Plus 2 times of 1 into dw by dt. Right? Because even the length and width are changing with respect to time. If they were not changing, this would have been 0. Okay, this would have not contributed anything. So this is as per the chain rule. So this would be, I'll directly do it because, well, it's not that hard. So we have this to be, length to be 8 and 6. Length is 8 and width is 6. So directly do this. So we have 2 into, well, it doesn't matter actually. It's 1. There's no L and W. But dl by dt is minus 5 and that is 4. So this would be minus 10 plus 8. So that would be minus 10 plus 8 is minus 2. Unit would be centimeter per second. Right? So what does it mean? That the perimeter is decreasing for every second. It's decreasing at a rate of minus 2. Okay, so let's have a look at the area. Area of the rectangle. We'll represent it as A of L comma W. That would be length into width. Now we'll differentiate A of L comma W with respect to time. So we have dA by dt, which is equal to chain rule. So we have this and differentiation of, so as per chain rule, we'll end up with such a thing. So differentiation of w to the power of 1 is 1 into w to the power of 1 minus 1, that is w to the power of 0. So all of this will give us the following, right? So let me make it clear to you guys. Let me do it here itself. Differentiation of L with respect to time will give us 1 because the power is 1 over here. So basically that would be 1 into L to the power of 1 minus 1. Okay, I think it should be very clear with all of this. I don't want to go in detail. And now here the width and the length has some contribution. So length is 8 while the width is 6. So we have the width to be 6 into rate at which the length is decreasing is minus 5. And this would be, length is 8 and the rate at which this is increasing is 4. So this is minus 30, 32. So this is 2 centimeter square per second. Okay, finally we can summarize the answer. The perimeter is increasing or decreasing at a rate of 2 centimeter per second. So this is very important. And the area increasing at a rate of 2 centimeter square per second. Again, unit is important. This is square, and that is, there's no square over here. It's linear term. So underline the important stuff. Right, guys? So this would be your answer. My bad. The time is minutes, not seconds. So all of this will change to minutes. If I have written seconds, then yes, I will lose half marks. So all these are in terms of minutes. So this is minute, 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 and minute. Okay, now I will not lose marks.